Hey everyone, welcome to another BTM screencast. And today you'll see that we're getting into roof framing. How exciting. So let's go over the different types of roofs, and the terms. So these are some common ones that you're going to see. So the first one is your gable, which fairly common. Uh, see those a lot, and this is actually one that you'll be framing. Second is a hip roof, so it looks like the gable, but it ends here, and then everything comes out on an angle. The intersecting roof, you can see, is a combination between the gable roof and the hip roof. The gambrel roof, you can see it's kind of different. It comes up, it's at sharp, well, not sharp angles, but it's angular as compared to the gable or the hip. The mansard roof, these aren't too common around here. Butterfly roof, which I've seen two of these in my lifetime. And the shed roof, which is common, it's just one angle. So let's talk about the roof frame members. So you can see this thing's nice and color coordinated. Let's go over them. So the first that we're looking for is the ridge board. Here it's indicated that it's black, and we can see that the ridge board comes up right here. That's the top of your roof. The common rafters, those are that nice shade of blue. So here we have common rafters. Then we also have common rafters over here, and then common rafters all in here. Next that we have are our hip rafters. So it's that nice red color. Here we have one hip rafter, and up here we have another hip rafter. The next that we have is the valley rafter, which is this orange color or maybe burnt sienna, depending on your color palette. And here we have that one coming up and down right here. The next that we have are the jack rafters. So if we look at the hip jack rafters, we have these right here. Now these are coming off the hip rafter, right? The next that we have are our valley jack rafters. So these are going down into this valley, right? Then we have our collar ties, which are in gray. So you can look in here and see where the collar ties are. We have our gable end studs, which we have here. You'll be cutting these for your performance assessment next week. Roof framing terms. So we have the unit run. Typically, they're 12 horizontal inches under a rafter. So our roofs are pitched, and pitch is slope, and slope is rise over run. So there's going to be some math involved in this. Lots of fun. The total span is the width of the building. So we're talking about from exterior wall to exterior wall. The unit rise is the amount a rafter rises vertically per unit run. So again, we're going in feet. So this is going to be how many inches for each foot is the rise. The total run is the horizontal distance from under the entire rafter. Now, the span and the run are two different things, because if you have overhang coming off of your wall, so if we had this and this is our wall, and we have our overhang coming off, right? Because our roofs typically don't end right where the wall does. So here's a pretty good diagram. We're talking about all of that. So we have our total span, and again, that goes from wall to wall. And then we have our rafter, our ridge, our total rise, and our total run. And this should be slightly extended out. Roof framing terms. So total rise, the amount the rafter rises vertically over its entire length. The theoretical line length is the calculated length of the rafter, which we'll be doing. The unit length is the length of rafter per unit run. continued terms, the pitch, it's the ratio of the rise to the span. So we'll probably be doing, it's called a 712 or 612 roof. The slope is a common way of referring to roof steepness, stated as unit rise to run. For example, 7 on 12. More roof framing terms. So a bird's mouth is a notch in a rafter where it rests on your wall plate. And this will look, if this is your wall, the bird's mouth is cut like this, but it goes around it. Kind of a bad picture, but as you know, I'm not an artist. The plumb line is any line on the rafter that is vertical after the rafter is installed. So when you lay these out, the plumb line is going to look weird. It's going to be at an angle. But when it's installed, and it's installed the way that it should be, it's going to be nice and plumb. The level line is any line on a rafter that is horizontal after the rafter is installed. So again, the plumb line won't look plumb until you have your rafter up. Just the same that the level line won't look level until your rafter's up. So here's some similarities and differences of rafters. So you can see that the valley rafter, the hip rafter, the upper end is supported by the ridge and the longer overhang than the common rafter. The common rafter, it's right up on the ridge, and a notch where the rafter is supported by the wall, and the tail extends past the building. The hip jack rafter, so this will land on that, and it has it's the same overhang as a common rafter, and it ends on a wall. When we have the valley jack rafter, so the upper end lands on the ridge, same. The lower end lands on the valley rafter, again, because those are at the bottom. So hips go down at an angle from the top, and the valleys are a valley, they come down into it. Jack rafters vary in length, yet have the same slope as a common rafter. So keep that in mind. We're not going to get into these unless you want to. If you do, let me know. And these are a little bit more complicated. They're more complex because there's multiple angles that you need to work with. Sizing rafter members. To begin sizing, the prints must be consulted. So again, you're just not going to say, you know what, I'm going to use this one because I have it laying around. Doesn't work unless you want to tear it out. It's the process similar to sizing joists. So major difference between joists and rafters is the span. For rafters, span is the horizontal projection of the rafter, not its length. So again, remember in the previous slides we talked about what the span is. Structural terms for rafters. So some terms that are used for joists are used for rafters as well. So on-center spacing, the material strength, the intended load, and the deflection limits. So the deflection limits refer to how much the wood is allowed to bend. So the different size wood is going to have a different deflection. A 2x4 is going to have more deflection than what a 2x6 will, which will have more deflection, which a 2x8 will. So the bigger the material, the less deflection it has. Determining rafter lengths. So we can do the step-off rafter method, which you'll be doing, or you could do the calculated length, which you'll be doing. So one, you take a framing square, and it's like you step it off. It looks like steps. The calculated one will actually pick a point, and then we measure it, and then go that way with it. So this is a good way, and it shows you on a framing square what this looks like. So this is letting us know where we're at. Now, typically we have a 16th inch scale, and we're used to using that. Well, when you look at a framing square, you have a 12th scale, which will really help us out when it comes to doing this. If we come up here and we go to our 7, then we can come down here, and you can see that at a 14-foot run, when we intersect it with our other square, it'll be 15-foot 8 length. So this actually does all the calculation for us. We don't need to worry about it. And this is what it looks like when you step it off. So we're going to start up here, and then where these points intersect, we just step it. So heel, 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 boom, there it is. It's relatively easy, and once you get this one done, you're able to use it as a template and reproduce it. So you're only going to have to step off once for the type of roof that we're going to be doing. So there's many styles of roofs. We're going to be focusing on the gable. Rafters have many names and component parts, so keep that in mind. We're going to get more in depth with this in the next set of slides. Rise, run, and length are terms used to define parts of the rafter. A unit triangle is similar to the house triangle. So there's going to be a lot of math involved. It's going to be a lot of fun, but you get to cut it and you get to build a roof. So it's not too bad. If you have any questions, let me know. If not, I'll see you next time.